Last class we had started with units and measurement, and we have seen how do we take a measurement of length, mass and time for a different ranges. That was for a large range and also for a short ranges. Today let us discuss about accuracy, precision of instrument and errors in measurement. Now, as we know that measurement is the foundation for the experimental science and technology. So anything that we measure from by experimental technique and the result that we obtain will have a certain uncertainty. Okay. Now what do you mean by uncertainty? This uncertainty itself is an error. Like we know that experiment measured values, we know some of the values. Okay. Like suppose if you have the acceleration due to gravity. The value of acceleration due to gravity is 9.8 meters per second square for that of the earth. Now, and we tend to do the experiment to find the acceleration due to gravity, okay, either by a simple pendulum or any other experiment. So what we obtain is we try to take that 9.8 meters per second square as the true value. But when we measure or when we do the experiment, we do not get a exact value to the true value. So then there is some uncertainty. We say that there is an uncertainty. So this we term to be as an errors. Now here I have written over here accuracy, precision of instrument. Now how do you differentiate between the accuracy and precision of the instrument? Accuracy means, so let us see what do you mean by accuracy. Okay. Now what do you mean by accuracy? Accuracy means the measured value, the measurement of the values, okay, the values that we calculate which is closer to that of a true value. Okay, I will give you some examples wherein you will understand what do you mean by accuracy. So it is a measure to see how close we are to that of the true value is termed to be as a accuracy. Then now what do you mean by precision? Okay, precision means it is the measurement to see the limit, okay, how the quantity can be measured, or it is to see at what resolution, okay, to see at what resolution or a limit in which the quantity can be measured, that we have is a precision. Okay, so what do you come to know the difference between the accuracy and precision? Accuracy means we calculate the calculated value, how much close to the true value. Okay, so in the measurement that we are doing, the value that you have calculated, okay, how much it is closer to that of the true value. And we have precision over here. What do you mean by a precision? Precision is the measurement, okay, it is also a measurement. It's to see what is the resolution, to see what is the resolution, or to limit a quantity is measured. Okay, so these are the differences that we have between the accuracy and precision. Now let me give you an example so that you will understand this accuracy and precision in more general. Okay, so here for example I will give that experiment they found the result, and in that result the true value was about length. Let me have length is equal to 3.678 centimeter. Now this was the experimental result in which they obtained and got the value of length L is equal to 3.678 centimeter. Now this is found to be as a true value over here. Fine. Now next what is done over here is, there were two persons. Suppose if you have A and B. Okay. Now a person A who does an experiment. Okay. And he gets the value, means he does the same procedure. Okay. Carries with the same procedure, same techniques he follows. And person A will get the answer to be about 3.5 centimeter. Okay, person A gets the answer to be about person A gets the answer 3.5 centimeter. Whereas another person B gets the answer which is about 3.38 centimeter. Now you know that I have mentioned that this is my true value, and based on this experiment was carried out by two persons A and B. Okay, person A gets the value as 3.5 centimeters and B gets the value of 3.38 centimeter. Now if I ask you that A and B, of which one is more closer to that of the true value, so you will say that person A is more closer to that of true value. So we say that in terms of accuracy, the value which has been calculated, the A value which has been calculated is more accurate to the value, to the true value. Okay. So in that case, A is more accurate than B. That is done. Okay. This is understood with the accuracy. Second one which we have is a precision. Now what do you mean by a precision? Let us take in this only. Now here you can see the resolution which is given over here is about, for this one it is 0.1 centimeter. Isn't it? After point you have only one digit. After decimal point you have only one digit. So the resolution over here is 0.1 centimeter, whereas in the case of B it is how much? After decimal point we have two digits. So for this one I have 0.01 centimeter. Understood? Now here in this case what we have is, you have, this is a resolution which is having 0.1, okay, and this is the one which is having higher resolution. Okay. So basically precision will tell you to what the resolution, or it will express to you the limit in which the quantity can be measured. So to look into that, we can see that B is the one which is having a more resolution as compared to that of A. So in that case what we have over here is, A is more accurate but it is less precise, and B is less accurate and it is more precise. Okay. So that is how we are going to see in this example. Okay. Similarly, we will be able to see the different kinds of errors. Okay. So these are the accuracy and precision in the instrument. Now why do we require, why need to study about the accuracy and precision? See, remember, if you don't succeed in getting the correct value to the exact value to that of the true value, then you will get the errors, and you will not succeed in getting the exact value. The result will always be wrong over here. So for that purpose we have to keep it in our mind about this basic accuracy and precision in selecting of a proper instrument, so that we can do our experiment, okay, and we can get a very good result through our experiment. Okay. So that is why we have to know that which experiment, which instrument, measuring instrument can be chosen to perform the experiment. Okay, so based on the accuracy and precision over here. Okay, so that we have is the accuracy precision of the instrument. Now let us see about the errors in measurement. Now errors based on, we have two different kinds of errors. Okay, so errors we have two different kinds. One you have is a systematic error, and second one you have is a random error. Okay, so these are the two errors which we have. Errors, we have systematic errors and you have the errors are random errors. Now what is this systematic error? Okay, systematic error is a one which takes place in one direction. Okay, which takes place in one particular direction, and this systematic errors, it can be either positive or it can be negative. Okay, so we did not say that errors can be positive only, so it can also be negative error also. We have certain kind of instrument where you will have the negative errors. Okay, like for example screw gauge. Okay, when we are going to find the zero error, we will have the positive zero error, negative zero error, then we find the error. Okay, negative. Then this will have certain sources. Okay, there are certain sources of the systematic errors. Now let us see which are the different sources of the systematic errors. Okay, now the systematic errors, I have sources are, we have three main sources. Okay, systematic errors, we have three main sources. One is measuring instrument. Okay, so first one what you have is a measuring instrument. So that is the first one which you have, instrumental errors, measuring instrument, or we have the instrumental errors. Okay, so we have measuring instrument error, or we have the instrumental errors. Now let us see what do you mean by instrumental errors. Okay, now for example, this instrumental errors which basically occur due to improper designing of the instrument. Okay, suppose if the instrument itself is faulty. Okay, faulty in the sense like it is not useless. I don't mean to say that. I mean to say that some particular readings, you have calibration when you are taking the readings, that readings will give you the written wrong values. Okay, so how we can have the instrument errors? For example is about a person who is doing the experiment to find out the temperature of cooling in time, let us say 5 minutes. Okay, so let us say a person has heated the water, and after to a certain range about 50 to 60 degrees centigrade, and after heating he is noting down the temperatures after 5 minutes. Okay, so after 5 minutes he will see that the temperature will fall. Okay, and after 5 minutes he is noting down particular temperature. Then after again 5 minutes, again noting down the second reading. After 5 minutes, again noting down the third reading. So likewise the temperature is decreasing over here. Okay, but okay, this is done, but he may not find the error in that case. But if he heat the water, okay, to its boiling point about 100 degrees centigrade. Okay, that is 100 degrees centigrade, you know, and he also knows that boiling point of water is about 100 degrees centigrade, but the thermometer which he uses, does not give him 100 degrees centigrade, but it will give him a larger value, which is about 104 degrees centigrade. So in that case, he found that the thermometer gives him the wrong reading. Okay. So in that case, the reading he has taken in all this experiment, that after 5 minutes, whatever he has noted down the temperature is found to be an error. Okay. Similarly, not only in the thermometers, we may also have other instrument, for example, vernier calipers. Okay. Vernier calipers is usually used to measure the length. Okay, from that of centimeter to meter range, it has been used to measure the length. And when sometimes this particular instrument, vernier calipers, zero of the vernier scale reading of the vernier calipers does not coincide with the zero scale of the main scale reading of the vernier calipers. Okay. So you have vernier calipers will have the vernier scale reading, 10 divisions will be there, and you have the main scale reading. So that 10 divisions, of which the first line which we consider to be as 0, if that 0 does not coincide with the main scale division, then there is an error in the instrument. So likewise, you may have sometime instrument itself, okay, starting whereas the pointer may not be at 0, okay, it may be below 0. So there also you will have the instrumental errors. Okay, that is about the first case. Second one is about the imperfections. In the experimental techniques. Okay, imperfections in the experimental techniques. Now what do you mean by imperfections in the experimental technique? For example, when a person tries to measure the body temperature, and if the thermometer has been placed under the armpit, so this value of the temperature will give you the lower value to the actual value which he or she was supposed to be taken. Okay. So in that case, there is a wrong method which has been used in that, due to which it can lead to an error. Okay. Sometimes maybe due to other conditions like temperatures may affect, wind also is there, air also is there. These all other conditions which may affect the imperfection of experimental techniques or a procedure. Then third one which you have is a personal errors. Okay, third one you have is a personal errors. Yes, so the word personal means it is due to the individual bias. Okay, sometimes when you do the experiment, okay, without taking proper precautions, without taking readings in a correct way, okay, if you do the experiment in the carelessness, yes, and if you don't observe carefully, okay, sometimes if you need to measure the pointer of the scale, so you may not have the pointer exact to that of the eye level. Okay, so there may be you will have the error due to parallax. Okay, so these are the different errors, systematic errors, and these are the sources of the systematic errors. Okay, so here these are the three main sources of the systematic errors. Now let us see about the random errors. Now what do you mean by a random errors? Random errors, the word itself tell you that it is the error which takes place occasionally. Okay, it takes place occasionally. So it is not a regular type of regular error which is taking place over here. Okay, so random errors will depend upon the sign and the size over here. Okay, so random errors, it will depend upon the sign and the size over here. Okay, now what can be the different types of a experiment is done based on the electrical experiment is done, that is verification of the Ohm's law, okay, then to find the resistance connected in series or parallel, that kind of, those kind of resistances if they are done, and if there is a fluctuations in the voltage, okay, if there is a fluctuations in the voltage, definitely will give you an error in the measurement. Similarly, if there is a mechanical vibrations due to the presence of a wind, if the mechanical vibrations are being produced in the experimental setup, also can lead you with an errors over here. So similarly, not only this, sometimes it can also happen when the person is doing the experiment, okay, and if he does the experiment, one time he will get one reading, second time he gets another reading, third time another reading. So this kind of cases where he will have the, every time he takes the reading, he will get the different values. So these are the main causes of the random errors which you have, okay. Now in this category, that is random errors, we have something called as a least count error. Okay, in this random error we have is a least count error. Now what do you mean by a least count error? First of all, what do you mean by a least count? Okay, now least count means like any of the measuring instrument will have the smallest value. Okay, so least count is the smallest value of the measuring instrument is known as least count. Least count error is the error which is present in the measuring instrument due to its resolution of the instrument. Okay, such kind of a error is known as a least count error. Okay, once again, least count error is the error which is present in the measuring instrument due to the resolution of the instrument. So here this we have this least count error belongs to the category of random errors, but also this least count can be present, can be there in the case of the systematic errors and also in the case of the random errors over here. So this we have is a with respect to errors. Okay. Now next what we do over here is for example how to minimize this errors. Now errors can be minimized. Okay. So how it can be minimized? First way to minimize the error is by making use of the proper technique, setting the experiment in a proper way, taking a proper precautions, selecting of a very good instrument. Okay, then also selecting the instrument which is more precise. Okay, so these are the experimental techniques, improving, then removal of the personal bias. All this will help us to minimize the errors while doing the experiment. Okay, so this we have is about the errors. Now let us see about some of the other errors and how do we measure those errors. Yes, some of the other errors in measurement we have is, we are going to study about absolute error. Then we have random error. Yes, what are the errors in measurement? Some of the errors in measurement, we have absolute error. Then we have relative error. And we have a percentage error. Okay, so we are going to study about each of them. What we have is absolute error, relative error and percentage error. Now let us see about the absolute error, the first one. Now consider that I am doing an experiment and I have taken many trials over here. So I have taken many readings over here and I note down my readings, that is A1, A2, A3, A4, so on, to I may have taken n number of times. So this is my, for example, I may take the reading of a simple pendulum and I may take the time period of the simple pendulum. These are my values. Okay, these are my values. Now here, what do I do over here is, I find that this value is more or less closer to that of the true value. So in order to have accuracy, what I will do is, I will take a mean of this. So therefore, A of mean will be equal to A1 plus A2 plus A3, so on to A of n, divided by how many numbers? Divided by the numbers of observation I have taken. If there is A1, A2, A3, A4, A5, then A1 plus A2 plus A3 plus A4 plus A5 divided by number will be 5 over here. So 5 trials I have done. Okay. So here A of mean is equal to summation of I is equal to 1 to n A of I divided by n. So what we are writing is, this full thing we are writing in terms of the summation. Okay. So this particular has contained all this value. So it is the limit which has been taken from I is equal to 1 to the last value n. Okay. So I will have it, I am going to sum it and divide by n will give me the A of mean. Now my main over here is, I have to find the absolute error. Now what do you mean by absolute error? Absolute error over here is, it is nothing but it is the magnitude of the difference between the quantity which has been calculated to that of the true value. So this absolute error, now this particular value A1, okay, this particular value A1 will have some particular error. This will also have an error. This will also have an error. This will also, all this will have a some error or not. Okay. So for that absolute error, okay, absolute error. So I am going to write this absolute error as delta of A1, that is the error in this measurement, is equal to this value A1 minus A of mean, which I am going to obtain from here. Similarly, delta of A2 is equal to A2 minus A of mean. Likewise, I will have delta of An is equal to A of n minus A of mean. So this will be my absolute errors. Okay. So what do I get over here is A1, okay, delta absolute error in the first one, A1 minus A of mean. Okay. So likewise I am going to calculate for the n numbers over here. Then next, after this, what I will do is, I have already got this many values. Again I will have to find the mean of the absolute error. So next what I will do here is, next I will take delta of A of mean. This I will take it as magnitude. Okay, I will take it as in the form of a magnitude, because some numbers, if I take a difference, it will be positive, some will be negative. But since I will have to take it in terms of the magnitude, so the absolute errors will be in positive. So therefore, delta A of mean is equal to magnitude of delta A1 plus magnitude of delta A2 plus magnitude of delta A3, so on to magnitude of delta An divided by n. Or I will write A of mean is equal to summation of I is equal to 1 to n delta of A of I divided by N. Okay, this we have got over here, and we have also calculated the mean of the values which I had observed. Okay, then how do I write my result? The result which I am going to write over here is the value in the result. It will take the value A is equal to A of mean plus or minus delta A of mean. Okay, so this is the arithmetic mean plus or minus delta, that is the absolute mean. Okay, mean of the absolute values. Now here, what does this plus or minus, what does it mean? What do you mean by a plus or minus? It means that the values which contain in A or the result A will be equal to A of mean plus delta A of mean, okay, and A of mean minus delta A of mean. So it will take a values, okay, this will be the result. It will take a values which is ranging between these two numbers. Okay, so what does in short to tell you that it will have the values A of mean minus delta A of mean, okay, smaller than A of mean plus delta A of mean. So your result will lie between these two values, these two ranges. So this is how what we have in the case of the absolute errors. Clear? So let us consider an example. Okay, these are the values which I have written over here. This is the reading that I have done from that of the simple pendulum experiment. And I have got the so many values of the time period over here. T1, T2, T3, T4 and T5. So this is my T1, this is my T2, T3, T4 and T5 I have. Okay. Then next what I will do over here is, I have calculated 1, 2, 3, 4, 5 values. Then I am going to find out my T of mean. Okay. So I will find out my T of mean, which is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80. So how many numbers it is? It is having 5 numbers. Okay. Then I will get my T of mean, which comes to be about 13.12 second divided by 5. Okay, which is about 2.42 seconds. Okay, this comes to be about 2.624. Okay, this comes to be about 2.624 second. So if I want to write, now after decimal point I have so many digits. So if I want to write in terms of only 2, so I can write approximately 2.62 second. This is the T mean that I am going to obtain over here. Next I will have to find out over here is, I will have to find out delta of T1, delta of T2, delta of T3, delta of T4 and delta of T5. So which is like T1 minus T mean, then T2 minus T mean, then T3 minus T mean, T4 minus T mean and T5 minus T mean. So this how much is T1 over here? I will have 2.63 minus 2.62. Okay. Then similarly what I will have is, I will have 2.56 minus 2.62. 2.42 minus 2.62. Then T4 is how much? 2.71 minus 2.80. Okay, then sorry 2.71 minus 2.62 and 2.80 minus 2.62 I will have. Okay, then next when I am going to find the difference over here, I will get this will be 0.01. Okay, so how much this will be equal to? See, this is greater than this, so it will be minus 0.06. This will be how much? Minus 0.2. This will be how much? 0.09 and this will be 0.18. These are the values that I will get over here. Okay, so you can see that this is positive, negative, negative, positive, positive. So this is my absolute errors in each of them individually. Then next I will take a mean of that. I will take a mean of that. So I will have delta T of mean. I will add that. Okay, I will take it as 0.01 plus 0.06 plus 0.2 plus 0.09 plus 0.18 divided by 5. This I will get it as equal to 0.54 divided by 5, which is equal to 0.11 second. Now this is your absolute error. Okay, so at last I will write my result. T is equal to, over here what was the mean that I have got? 2.62. Okay, 2.62 plus or minus 0.11. So what does it mean is, it will take a number 2.62 plus 0.11 or 2.62 minus 0.11. So how much it will be? Here it will be 2.73 and here it will be 2.51 seconds. So basically it means that it is between 2.6. Okay, so this is between these ranges. So that is how I am going to calculate my absolute error over here. Fine. Now next we have is about the relative error. Let us see what is the relative error. Next one will see about the relative error. Next we will see about the relative error. Relative error is nothing but it is the ratio. Okay, relative error is nothing but it is the ratio of the absolute errors. So if I write absolute error, mean of the absolute error to that of the arithmetic mean of the value. Okay, so relative error I will have delta A of mean divided by delta A of mean divided by A of mean. So it is the ratio of the mean of the absolute error to that of the mean of the value. Okay, so this is my relative error, and we have a percentage error. Percentage error is usually denoted by delta of A, which is nothing but this relative error. When it is expressed in terms of the percentage, we write it as a percentage error. What does it mean? That delta A of mean divided by A of mean into 100. Okay, so this will be expressed in terms of the percentage. Okay, this will be expressed in terms of the percentage, and this will give me the percentage error and the relative error. Okay. So examples we can have, for example, if you are given an example, that is the voltage V is equal to, I have example over here is V is equal to 100 plus or minus 5 volt and I is equal to 10 plus or minus 0.2 volt. Okay, this is the example which is given to you. So in this case, I will have to find out the error in the resistance. I know that resistance R is equal to V by I. So here, what will be the error over here? V is equal to, I will have delta V. Error in V will be delta V by V. How much it will be? Error in V, delta V by V, how much it will be? 5 divided by 100. Okay. So 5 is the absolute error. Okay, to that of the value. So this will be how much? 0.05 will be the error in V. If I want to measure in terms of percentage, I will multiply this by 100. So this will give me 5% in terms of the percentage error. If I want to find out the error in I, so it is absolute error is how much? 0.2. Value is given to you as 10. So how much is the relative error over here? Relative error it will be 0.02 and this will be the relative error. If I want to calculate the percentage error, you have to multiply this by 100. So this will be how much? It will be 2% will be the error in the current. Clear? So that is the voltage, it will have 5% and current it will have 2%. Okay. So with this we'll end with the session and we'll continue in the next class. Thank you, students.